All right, let's put on our detective hats for a bit, because we're about to crack a mystery that every single person who works with data runs into. We're talking about the case of the missing data. Let's get right into it.
Think about this for a second. The biggest threat to your analysis isn't always the information you have that's wrong. Sometimes it's the information that's just not there. These gaps, these silences in your data, they can tell a story of their own, or even worse, they can mislead you into drawing completely wrong conclusions.
You see, this is the perfect way to think about it. If you're reading a story with words missing, you might be able to guess the meaning, right? But you can never be 100% certain, and those missing pieces create a ton of uncertainty, which can lead to biased, totally unreliable results. Our job as data detectives is to figure out how to fill in those blanks responsibly. So, what are we really dealing with here? Missing data is an incredibly common thing. I mean, we see it everywhere. Incomplete surveys, people dropping out of a study halfway through, or even just simple data entry mistakes. It's not a sign that your data is bad, it's just a reality of collecting it in the real world.
Okay, so when you see a gap in your spreadsheet, what's the first most tempting thing to do? Just get rid of it, right? Delete the entire row. This is called list-wise deletion. But, and this is a huge but, it's like a detective arriving at a crime scene and throwing away a piece of evidence just because it's a little smudged. If that missing data isn't random, you risk systematically throwing out a huge part of your story, and that will absolutely bias your final conclusions.
So, to solve this case, we can't just jump to a fix. A good detective has to understand why the evidence is missing in the first place. The reasons behind these gaps are our clues, and they basically fall into three main categories.
First up is what we call missing completely at random, or MCAR for short. Now think of this as a pure accident. A survey participant just accidentally skips a question, or a piece of equipment has a momentary glitch. There's no rhyme or reason to it. The missingness isn't connected to anything else you've measured. Honestly, this is the simplest scenario, and it's also the rarest.
Okay, now let's tweak that scenario. What if the reason somebody skipped a question can be predicted by their other answers? For instance, maybe you notice that older participants in your study are way more likely to skip a question about their technology use. Well, now the missingness isn't completely random anymore, is it?
And this brings us to our second big clue, missing at random, or MAR. Now, I gotta be honest, the name is a bit misleading. The data isn't missing at random in the way we normally think of it. What it really means is that we can use other information we do have in our data set to predict where the gaps are. We can't see the missing value itself, but we can see its footprints in the other data points we've collected. Here's a classic example. I bet you already know the answer. Let's say you send out a survey, and one of the questions is about income. You start getting the results back, and you notice that the people with really high incomes are the ones most likely to leave that field blank. Is that random? No way. The chance of that data being missing is directly tied to the value of the income itself. And this leads us to our third and by far most challenging clue, missing not at random, or MNAR. This is the trickiest one to solve, because the reason for the gap is the very information we're missing. So for example, people with the most severe depression might be the most likely to skip questions about their mood. The missingness itself is the data. So, we've identified the clues, we know what kind of missingness we're dealing with. What's next? Well, every good detective needs a toolkit, and in data analysis, that means having a whole range of methods to handle these missing values. We've already talked about list-wise deletion, just tossing the evidence. The alternative is something called imputation, which is a fancy word for filling in the gaps. The most basic type is single imputation. This is where you make one educated guess, like replacing a missing number with the average of all the other numbers. It's simple for sure, but it can create its own set of problems. But why rely on just one guess? A much more powerful technique is multiple imputation. Instead of just plugging in one value, it actually creates several different complete datasets. Each one has slightly different but totally plausible estimates for that missing data. It's kind of like bringing in a whole team of experts to consult on the case. It gives you a much more accurate, much more robust result because it actually accounts for the uncertainty of your guess.
And the crucial thing to get here is that each of these tools has its own trade-offs. List-wise deletion is super simple, but it's often biased. Single imputation is also pretty easy, but it can really mess with the variability in your data. And multiple imputation is the most accurate, but yeah, it's also way more complex to pull off. There's no single best answer.
And believe it or not, our toolkit is even bigger than this. There are other advanced methods out there, like pairwise deletion, which is a more surgical way of removing data. You've also got things like weighting, which adjusts how much importance you give to the data you do have. And for the really complex cases, there's a powerful statistical method called full information maximum likelihood, or FIML.
Okay, so with all of these tools at our disposal, how do we actually choose the right one for the job? A great detective doesn't just grab the first tool they see, they assess the whole situation and make a strategic choice.
It really boils down to a pretty simple three-step process. First, you analyze your clues. What type of missingness are you dealing with? MCAR, MAR, or MNAR. Second, you define your mission. What's the question you're actually trying to answer with this analysis? And third, based on those two things, you pick the right tool for your specific data set and your specific goals.
And here is probably the most important takeaway of this whole explainer. There is no magic bullet for missing data. There just isn't. The right choice is always context-dependent. What works perfectly for one analysis might be completely wrong for another. It's all about being a thoughtful detective, not just a button-pushing technician.
So, we've analyzed the clues, we've reviewed our toolkit, now it's time to bring this case home, to move from the gaps in our data to solid, reliable conclusions.
Because here's the ultimate lesson. You will almost never have a perfect, complete data set. It just doesn't exist. The real skill of a great data detective isn't in avoiding problems, it's in knowing how to handle those inevitable imperfections thoughtfully and correctly.
So the next time you run into missing values, don't just see them as an annoyance. See them as part of the story, because sometimes what isn't being said is just as important as what is. Are you listening?